Alright, today I want to show you lesson 10.6 factoring a quadratic in the form of ax squared plus bx plus c. And the method we're going to use for factoring is a little different than the textbook, and so you should copy the next slide down. These are the 5 steps that we're going to use for factoring. These steps are a little more methodical, and a little confusing at first, but once you go through them, it's an easier process than the process in the textbook. The textbook is a fine way to learn how to factor. It's how I was taught and many of your parents were taught. However, given that we will not have several days to practice, this method is probably better than the one in the textbook. The textbook is fine for if you've got time to practice, and we just don't spend that much time on factoring. So my suggestion would be to pause this slide, copy these 5 steps down, and then resume once you have them copied down. Alright, so we're going to continue, assuming that you've already copied these down. So here's our first one, and step 1 says find the greatest common factor. So we looked at the 3 terms, the 3x squared, the 5x, the 2. There is no number that divides out of all 3 of those. There's no variable that divides out of all 3 of those. So the greatest common factor is 1. And when the greatest common factor is 1, then we just kind of skip that step. And that happens quite frequently. Step 2. Find 2 numbers whose product is a times c and whose sum is b. Now remember, in Chapter 9, quadratic equations are in the form ax squared plus bx plus c. So in this case, our a term is 3, our b term is 5, and our c term is 2. And so what we do is we take a times c, so that's 3 times 2, and that gives us 6. Then the middle term, the b term, is 5. So we need to find 2 numbers that multiply together to give us 6 and add up to 5. And this can be hard for some people, but with a little bit of practice you can get pretty good at that. The answer is 3 and 2. 3 and 2 multiply to be 6 and add up to 5. Now we're going to use these numbers to help us factor. So step number 3 says rewrite the expression changing b into the sum of 2 numbers found in step 2. So what we're saying is we're going to take this middle term, this 5x, and instead of writing it as 5x, we're going to write it as 3x plus 2x. And that's going to break this down into 4 terms. And so when I rewrite the quadratic equation, I get 3x squared plus 3x plus 2x plus 2. Because what we're doing in this lesson is doing the opposite of lesson 10.2. Instead of multiplying binomials together to get a trinomial, we're going to take a trinomial and break it down into the product of 2 binomials. So that's step 3. Step 4, it says factor out the first 2 terms of the new polynomial, then the last 2 terms. So in essence, we're taking this polynomial and we're going to break it in half. And we're going to look at the first 2 terms and say, what can I pull out of 3x squared and also 3x? What divides evenly out of both of those? Well, I can divide a 3 out. Most people see that. But I also can divide an x out. Now, I'm going to put parentheses, and we're doing the opposite of the distributive property. And what I want to know is 3x times what will give me this 3x squared? Well, 3x times x is 3x squared. And then 3x times what gives me 3x? Well, 3x times 1 is 3x. And so I've broken this two terms of this polynomial down into a mini distributive property. Now I'm going to do the other side. And I say, okay, what can I divide out of 2x and 2? Well, I can take a 2 out of 2x and 2. So I pull a 2 out, and I do the same thing. 2 times what will give me 2x? Well, x. 2x times what will give me 2? 1. Now at this point, I look at my two set of parentheses, and both sets of parentheses should be the exact same thing. If they're not, I have not factored this correctly. Now I still have one more step, and that is factor our result here. In essence, we've taken a 4-term polynomial and taken it into two big terms. One term is 3x times x plus 1. The other is 2 times x plus 1. And so if I look at each one of those terms and say, well, what's in each one of those that I can divide out? What's in each one of those I can divide out? Well, there's an x plus 1 in the first one, and there's an x plus 1 in the second one. So I can divide that x plus 1 out. Well, when I divide it out, they cancel out, and what's left? Well, there's still this 3x left, and there's still this plus 2 left. And so that's my second binomial, 3x plus 2. And that is this trinomial factored out. Now, how do I know for sure that it is? Well, I could remultiply just to check. If I took x times 3x, I get 3x squared. X times 2, I get 2x. 1 times 3x, I get 3x. 1 times 2, I get 2. Combine like terms, I get 3x squared plus 5x plus 2, and that's what I started with. And so it is the right answer. So what I have here in the red box, the x plus 1 times 3x plus 2, that is the final factored form of 3x squared plus 5x plus 2. All right, that's one example. I assume that you're still a little confused. It's going to take 3 examples. So let's do another one. Here I have factor 4x squared plus 42x minus 22. All right, step 1, find the greatest common factor. So I look and I say, is there anything I can factor out of all 3 terms? And the answer is yes. I can divide a 2 out. So 4x squared divided by 2 is 2x squared. And 42x divided by 2 is 21x. And negative 22 divided by 2 is negative 11. So I got this 2 out front by dividing all 3 terms by 2. I have to keep it there. It just stays out front. Now step 2, 2 numbers whose product is a times c. Well, a times c, 2 times negative 11, is negative 22. The middle term is b, it's 21. So I need 2 numbers that multiply together to be negative 22, but add up to 21. Okay, this is hard for some people. And if you haven't thought of it by now, that's okay. But the answer is positive 22 and negative 1. Those 2 multiply to be negative 22 and add up to positive 21. So step 3 says, change this middle term to be 22x minus 1x. So I'll rewrite. Still have the 2 out front. I have 2x squared plus 22x minus 1x minus 11. Now, step 4 says break this in half. I still have my 2 out front. what can I factor out of these first two terms? What can I factor out of 2x squared and also 22x? Yes, I can factor out a 2, and I can factor out an x. 2 and an x. What's left? Well, 2x times x is 2x squared. And then I say, well, 2x times what gives me 22x? Well, 2x times 11 gives me 22x. Then let me try the other side. Well, as I look at the other two, I see, well, there's really nothing I can factor out of those two things. Well, two pieces of advice. If the first term here, if that's a negative, which it is, then pull out a negative. Divide out a negative. The second piece of advice, if there's nothing to pull out a 1. So I'm going to pull out a negative and a 1, which is negative 1. So I'm going to factor out negative 1. And I say negative 1 times what is negative x? Well, x. And negative 1 times what is negative 11? Well, 11. Now my two set of parentheses are exactly the same. That's good. And so the last step is look at the two big terms that you have, and what can you pull out of both of those? What can you divide out of both of those terms? I still have my 2 out front, but what I can factor out of those two new terms is an x plus 11. There's an x plus 11 in both of those. And when I take out the x plus 11, I'm dividing out, they cancel, they're gone, then I'm left with 2x and negative 1. And so it's 2x minus 1. And so this is your final factored form. All right, we're going to do one more. And after the third one, then I'm hoping that you'll be able to use the notes that you took and use these examples that you've written down, and with the notes and the examples that you would be able to do one by yourself without my help. All right, so let's do this last one. First, find the greatest common factor. So I look at 7 and negative 4 and negative 3, and there's nothing that divides evenly into all those except 1. So I'm skipping that step. The second step says take A times C. Well, 7 times negative 3 is negative 21. And the middle term is negative 4. So I need two numbers that multiply together to give me negative 21, but that add up to negative 4. And you will get good at this. And the answer is negative 7 and positive 3. Those two numbers multiply to be negative 21 and add up to negative 4. So I rewrite my middle term to be negative 7x and positive 3x. And some people ask, does it matter what order that I put those in? And the answer is no, it doesn't. You'll still get the same answer in the end. The work will look different, but the last answer will be the same. So I rewrite 7x squared minus 7x plus 3x minus 3. Next step is break it in half. What can I factor out of the first two terms? Well, I can factor out a 7 and an x. And what's left? 7x times x is 7x squared. And 7x times negative 1 is negative 7x. And then I look at the next two. What can I factor out of those? Well, I can factor out a 3. 3 times x is 3x. 3 times negative 1 is negative 3. And so I look at my parentheses. They're both the same. That's good. Last step. what's the same in this term as in that term. And I look at them and I see an x minus 1 in both. So I divide out the x minus 1. When I divide it out, what's left over? Well, there's still this 7x and this positive 3, and so it's 7x plus 3. And that is your final factored form. And again, you can check it by taking the x times 7x, the x times 3, the negative 1 times 7x, and the negative 1 times 3. Combine like terms, and you should get 7x squared minus 4x minus 3. And that is what you get, so that is the final factored form.